Hi guys. Sorry this first of all didn't get up last night, but so we're gonna start optimization problems. Optimization problems are really just a fancy way of doing maximum and minimum problems. You're applying them to actual situations. They're equations that are more like a system of equations than just having one equation, taking the derivative, finding increasing, decreasing, etc. So here are some guidelines. You want to identify the given quantities and quantities that you need to determine. You're going to write an equation for the quantity that is to be maximized or minimized, and then you're going to have a second equation. So if you're doing a volume problem, you're going to use volume and surface area, most likely. If you're doing an area problem, you're going to do area and perimeter. Those will be your two equations, and you'll solve for one of them to put them into one variable. You'll reduce the equation to a single independent variable, determine the domain, and then determine the max or min by using the first derivative test, critical numbers, and things that we've done. Also remember to feel free to pause this at any time. So example 1. A manufacturer wants to design an open box having a square base. So if it has a square base, think about what that means about the bottom of the box. And a surface area of 108 square inches. So what is surface area? Okay. Remember the box is open, so we don't count any of these flaps at the top. We're only counting the, let's see, 1, 2, 3, 4, and then the bottom, so 5 sides. What dimensions will produce a box with a maximum volume? So first of all, think about what your two equations you need to be. We'll label this x, because we have a square base, and then the height, so from here to here, h. So what two equations do we need? And then write the equation. So take a second and try and do that. Again, go ahead and pause this at any time. Keep in mind we're asking about volume. So how do you find volume? Volume is normally like length times width times height. But in our case, our length is what, and our width is what, and our height is used what. So volume equals x squared, because you have the square base, so x times h. Surface area is x squared, our square base, plus 4 times x times h, because we have 4 sides with lengths x and h. Remember the top, we're not counting the top flaps because it says it's an open box. So the next page I'm going to work through the problem. So again, pause it at any time. Or actually it's page after the next page I give you the steps. So pause at any time and work through it on your own. That's what I would prefer. So to optimize the volume, these are the 5 things you're going to do. You're going to solve the surface area for the equation, surface area equation for h, substitute that into the volume equation, find your domain from this equation here, and then find your critical numbers and evaluate at critical numbers to tell you what the answer. So I'm going to go back for a second. So define what dimensions will produce a box with a maximum volume. Okay. So again, when I go to the next page, I'm going to be flipping through the answers quickly. So I would like you to pause it and do this on your own, and then check your work. So, step 1, we solve this equation for h. Why h? Because h is in my volume equation, and it's easier to solve for than x. Say x. So we're solving for h, and then we're going to substitute this equation into the volume equation. So to do this, all I did was subtract x squared and divide by 4x. I was isolating the variable. When I substitute it in for h, my volume was x squared times h. Now it's x squared times this quantity. So you're just taking this h and replacing it into here. When you distribute, so I distribute my x squared, this is what I get, 108 x squared minus x to the 4th over 4x. So all I did was distribute. So now I'm working towards simplifying this equation. I split them up into 2 different fractions, and it leaves me with 27x minus x cubed over 4. What is my next step? What do I need to know? I need to know my domain. So based on this equation, or you can use this one, but I'm going to use this one because it will make it a little bit easier. What is your domain? What's the most x can be? What's the least x can be? So 0 is less than or equal to x, which is less than or equal to 108. You can't have dimensions that are less than 0. And the 108, if I took 108 minus the square root of 108 squared, that would give me 0 on top. So that's where that comes in. 4, you need to find your critical numbers. So remember what that means. To find your critical numbers, what do? You're going to take the derivative of this and then set it equal to 0. So again, I'm going to be flipping through these, and I need you to work at your own pace. So pause it at any time. So the derivative of the volume with respect to x gives you 27 minus 3x squared over 4. All I did was, this was 1/4 x to the third, remember? So bring it down, excuse me, and then I'm going to set it equal to 0, and you're going to solve. So we get 3 over 4 x squared equals 27. You multiply 27 by 4, so 3x squared equals 108. So x equals 6. Now x actually equals plus or minus 6, but why would I choose only the positive? So think about that. Because of my domain. Okay, I can't have negative numbers, so I just left it out. Okay, step 5 is to, oh, whoops, I'm not sure about that 108, but that's okay. So what does the critical number tell you? What do we need to find in order to find the maximum? So what does that give us? What can we do with that? So think about our charts that we did. You're going to use your critical number and your domain to find what? Where your problem is increasing and decreasing. So 0 was one of my numbers. 6 was going to be 1, and then square root of 108. So at 0, the volume is 0. At 6, my volume is 108, and at square root of 108, my volume is 0 again. So where is it the most? It's at 6. So the volume is maximized when x equals 6. If x equals 6, then h has to be 3. How do I know that? Well, 6 times 6 is, because 6 times 6 is 36. I'm plugging back into the surface area equation. So 6 times 6 is 36 plus 24h, so it's x squared plus 4xh equals 108. So when I solve that, I get h equals 3. So that's where that comes from. So you plug it back in and you solve for h. So example 2, this one you're going to need to pause. This one I don't go through all the steps on it. I will be putting my solution process up later today though. So determine the dimensions of a rectangle. That should be rectangular salad with a square base with a maximum value if its surface area is 337.5 square centimeters. So these are the things I want you to do. Determine equations, solve for one variable, substitute into the other equation, determine domain, critical numbers, maximum value, and volume and dimensions. So because it gives you surface area and it's talking about volume, you're going to use the volume and the surface area equations again. So go ahead, work through that. Again, on the next page it shows just the solutions without steps. So do not click till you've finished. So your equations are 2x squared plus 4xh. This time it didn't say anything, I'll go back, about an open box. So that's why we have the 2x squared, because we have the top and bottom and then the 4 sides. Solving for one variable, and you get everything to be 7.5. Again, I'll be posting full solutions to this later. These are your homework problems, so these I will be collecting when you get back. So if you have questions, you need to email and ask, or ask on Edmodo so others can respond to them as well. The The first one is about volume. So it gives you three different rectangular things, and I don't have a picture for them, sorry, but picture them like the first box that you saw, and you're just verifying that they're 150 square inches. And then find the volume of each salad, and then determine the dimensions of a rectangular salad. So you're doing what we did. The second one, you have area, so you're going to use area and perimeter. And the third one, again, you're going to have to graph this line and then use area and perimeter. So it's going to be a triangle, the third one. If you have questions, again, please ask. Have a great day, and I will be posting another video hopefully tomorrow night.